Okay, we are in the end times of the reviewing for Chapter 4. This is just a little extra review that's in your notes. If we were in class, what I would have you guys do is kind of do these by yourself. I'd walk around and then kind of check up with how you are doing. So that's kind of what I'd like you guys to do. I'll kind of introduce and then kind of talk you through a couple things, but the best thing to do would be to pause the video, see what you can do on your own, and then double check. Sound good? Okay, example 1 says the following data values represent test scores by one class after they received a series of reading activities to help improve their reading skills. And what I'd like us to do is to make a histogram for this data. Now, do we need a 5-number summary for a histogram? We don't. But what we do need for a histogram is we need a frequency table. And when we make a histogram, I'm even going to just call this a frequency histogram as opposed to a relative frequency histogram. The relative frequency, we put things into percentages or decimals. Here we'll just kind of make the as it is. So remember that we're going to have a class. Oh my gosh, that has too many S's. So we have something that has a class, and then we're going to have the frequency of each class. So when I look at this, the values, I see that my smallest number appears to be 10. And my largest number appears to be 79. And remember, my goal is to have between 5 and 10 different classes. So if I went by like 50s, clearly that wouldn't be good because I would just have 0 to 50, well, 0 to less than 50, 50 to less than 100. That's not enough. If I went by 20s, that might not even be good as well. If I went by 5s, that might give me too many classes. So I think going by 10s would be a good idea. So I'm going to go by 10s. And when I construct my classes, I want to go from 10, and then we're going to say to less than 20. The next class would be from 20 to less than 30. From 30 to less than 40. And constructing our classes in this way allows us to have, basically to cover all of the different values of, in this case, the test scores that could feasibly happen. If I just went 10 to 19, then if I had a score like 19.5, that wouldn't work out. But the end of one class should always be the beginning of the next class. And this gives us a nice continuous piece. So when we make our histogram, that's the case as well. Okay? So again, we made the classes. I'm going to ask that you pause the video and that you try to do this next part on your own, okay, where we're going to put the frequency of each class in there. If you're not pausing, then here's what it's going to look like. We're just going to work through the different values that are here. So 42 would go in the class from 40 to less than 50. 43 goes in that same class. 55 would go in the class from 50 to less than 60. 26 would go into 20 to less than 30. 62 would go 60 to less than 70. 37 would go 30 to less than 40. 33, 30 to less than 40. 41, 40 to less than 50. 19 would go right here, 10 to less than 20. 54, 50 to less than 60. And then here's this 20. Remember that this class is 10 to less than 20. I can't get to 20 until I go to this class, 20 to less than 30. So this 20 is going to go in this class. 79, 70 to less than 80. 46, 40 to less than 50. 10 would go to 10 less than 20. 17, 10 to less than 20. 70 has to go to the 70 to less than 80. 60 would go in the 60 to less than 70. 53, 50 to less than 60. 42 is here, 40 to less than 50. I did that one. 37, 30 to less than 40. 42, 40 to less than 50. 55, 50 to less than 60. 28, 20 to less than 30. And 48, 40 to less than 50. Okay. So hopefully if you've unpaused, then you've got these correct frequencies. And so the next thing we want to make sure that we do with the histogram is make the axes correct. Okay. And when we make the axes correct, we want to make sure that our bars for the histogram are these different classes. So I might start, I don't know, maybe I'll start here. And I'll call this 10. And I'll go 3 over, and this will be 20. I'll go 3 over 30. And then I'm just making sure that the bars are each the same width because our classes are the same width. Okay. And I would label these with the units. These are test scores. It didn't say if it was like points or percentages. So I'm just going to label this down here, test scores. Okay. Now on the vertical axis, I see that I'm going up to 7. And so I can go by ones and fit up to 7 pretty well. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is going to represent the frequency. So the frequency is saying, how often did those happen? And then now is the fast part of our histogram, where we're just going to draw bars up to the appropriate frequency. So 10 to less than 20 had a frequency of 3. So 1, 2, 3. 20 to less than 30 also had a frequency of 3. That's the nice thing about setting these up, is that they're going to bump right into each other. 30 to less than 40 will also be 3. 40 to less than 50, we have to go up. So 3, 4, 5, 6, 7. 50 to less than 60, we have to go to 4. 60 to less than 70, oops, we're back down to 2. Not 3, sorry about that. Okay, and then 70 to less than 80, we're also down to 2 there. Okay, and again, traditionally, to help people from far away see, we traditionally do shade in the bars of our histogram, just so that it's a little easier to see what that shape is. Okay, Now there's one thing our histogram is missing. What could that be? That's right, a title. So let's see, this was after they received a series of reading activities. So we could say like post reading activities. Not the best real descriptor there, but from what they gave us, then we're good. Okay? So that's a very nice histogram. And now that we have this histogram, which we did in topic 1, we're going to write a few sentences describing the distribution of the test scores, which we learned about how to do in topic 3. Remember, when we talk about describing the distribution of the test scores, we always want to talk about our shape, outliers, center, and spread. And the thing with the histogram is that we can tell what the shape is pretty much from the histogram. What would you say the shape is? I think it folds down the middle pretty nicely. And so I could say that this is roughly symmetric. But we can't say anything about outliers unless we check the formulas. And we can't give specific measures of center like the mean and median or the range and IQR unless we put the values in our calculator. So let's go ahead and do that, and then we can try to get some more information about that. So again, I'm going to go to Stat, Edit, and I'll clear everything in the lists and then put everything, all of these data values into the calculator. Make sure that you're entering them in accurately. I'll often go back through and make sure that I have everything in an appropriate list, that everything looks good, like reading forwards and backwards, backwards and forwards, etc. And then what we can do from here is we can go to Stat, Calc, and then the one variable stats. And let's review some of the things that the one variable stats can tell us. One thing that the one variable stats can tell us is this X bar. This X bar is going to be our mean. So the mean of our data, this over here, the mean of our data is going to be about 42.5. Okay. We can also arrow down for that 5-number summary. Maybe you want to write the whole 5-number summary down, that our minimum is 10, Q1 is 30.5, our median is 42, Q3 is 54.5, and our max is 79. Okay? And then from those, we can find some other special pieces. So one of the things that we can find from those special pieces is that if we use our minimum and our maximum, we know that our minimum and our maximum can give us our range. And so we can take 79 minus 10 to give us that 69 for our range. We also know that we could take our Q1 and Q3 and we could subtract that for the IQR. So 54.5 minus 30.5, and that gives me 24 for my IQR. And then our median is going to be this number that's in the middle. So those are the measures of center and spread. And we really should check for outliers. It doesn't look like there are any outliers, but sometimes they can be hidden in there. And it's just good to practice the outlier formulas with you guys. Remember that the outlier formula, like for the boundaries, are Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. So my Q1 here was 30.5, oops, sorry, 30.5 minus 1.5 times 24. And Q3 was 54.5 plus 1.5 times 24. Let's see what those boundaries are. So I'm plugging this in, 30.5. You don't have to see my screen. You guys know how to substitute in. And when I'm substituting these in, I am getting negative 5.5 and 90.5 for my boundaries. Okay. And when we look at the data that we have here, we don't have any values that are below negative 5.5. Our highest was 79. So everything was within these boundaries. So there are no outliers, which we kind of expected. So now that we have all of that information, we can write about our description. So our shape, I believe this is roughly symmetric. So I'll say that this distribution is roughly symmetric. With no outliers. Later. The mean is 42.5, and I don't know what the unit is on that. So the mean is 42.5, and the median is 42. And I like looking at the mean and the median. They're about the same, right? When the mean and median are about the same, that means that they're probably roughly symmetric. Okay. Then the range, we said, is 69, and the IQR is 24. And again, I would have given units for this, but it didn't say if these were in points or percentages or what. So that's all I could do for something like that. Okay. So look, we reviewed topic 1 on histograms and topic 3 on describing distributions. So let's look what's next. In example 2, it says the following data values represent the male and female weights in pounds of top athletes here at PSEP. It asks us to make comparative box plots of the data and then compare the distributions. So we have distributions for the female weights and the male weights. We have those here. Okay. So again, if we were in class, what I would have you guys do is I'd have the females find the 5-number summary for the female weights, and I'd have the males find the 5-number summary for the male weights, and then we would put them in here and then label appropriately. Okay, so take a minute, pause the video, and find your what your 5-number summary would be, and then we'll share. Now the question is, did anyone really pause the video or did you just wait for me? Anyway, so here's what I came up with for the female weights the minimum 93, Q1 106.5, median 121, Q3 146, max 185. Okay. And for the male weights, I had 97, 129, 154, 172.5, and 210. So notice that I tried to put these box plots on here, and we can kind of see which one is which. We can see that the female one is only going to go from about 93 to this 185, and the male one is going to go a little, start a little bit farther here, 97 to the 210. So I guess I can try to mark what these are here. This looks like this was going to be 90, and maybe this was 100. I might only mark yeah, that looks pretty good. I'll just only mark every 20 in that case, just so it's not so crammed. And then these are the different weights. And goodness gracious, I didn't say if these weights were in pounds or kilograms or what. I need to get it together here. So we'll just say that these are weights. And then it does look like for the females, we have a minimum of 93, a Q1 of 106.5. It doesn't really look that good, does it? Oh, here's 106.5. That looks fine. Okay. Sorry. Median of 121, Q3 of 146, and a max of 185. So we should label this one then the female one so people know what we're looking at. And the same thing for the male. Here's the minimum at 97, Q1 at 129, our median at 154, Q3 at 172.5, and our max over here at 210. We'll label this for male. Okay. And then we'll also put here up top, these are supposed to be the top athletes. At PCEP. Okay. Now, normally what we would want to do is we would want to check to see if there are outliers. But because of the graphs that are being shown, what does that tell you? If the graphs are correct, what does that tell you about the outliers? That's right. What that tells us is that because there were no outside dots marked, there are no outliers present. And I'll tell you, of course, you know I double checked and I did the formulas for the females and for the males, and neither of them have any outliers. Okay. So now that we have that, what we can do is maybe compare the distributions. Okay. So the box plot helped us review topic 2, and now letter B will help us review topic 4 as far as comparing the distributions goes. Okay, so when we compare the distributions, we still use that idea of the shape, outliers, center, and spread. We still want to talk about all 4 of those different pieces. So let's look. I look here, the female looks like it's more skewed right. Looks like there's a bigger pull to the right. and the males looks like it's a little more symmetric. Maybe skewed a little to the left, but more symmetric. So that's what I'll put here. I'll say that the female distribution is skewed right. Well, the male distribution is more symmetric. Okay. Again, if you said slightly skewed left, I'm okay with that. Okay. So we've talked about the shape. Now outliers. Well, neither distribution has outliers. That makes it easy. If we did, we would say which distribution had an outlier or outliers and what those values were. Now for center, when we're doing this for, when we're comparing distributions, I know I have exact values for the median, but we're not going to talk about the exact values. We're just going to compare them. And so what we see is that the median for the male distribution is higher for the females. And because we're talking about weights here, that means that typically that the male top athletes weigh more than the female top athletes. And that's the inference that we want. We're not going to use any specific numbers. We'll just say the median is higher for the males than for the females. And that means that typically male athletes weigh more than female athletes. Again, that's not always true, but that's just typically speaking because of where we see the center. Okay. Now we look at the spread of the data, and the nice thing about the box plots is that we can tell the range by looking at our max and our min. And we can see that the range for the males is a lot more spread out than the female. So the female has a smaller range. And let's see, what about the IQR? Oops. The IQR, remember, is how big that box is. Well, and the IQR is about the same. But I think the IQR does end up being a little smaller. So we can say that the range in IQR are both smaller for female athletes, meaning their weights are more consistent than the males. Okay. So that would be comparing the distributions. Notice in the comparison, I don't put any numbers. What I try to do is just look at the values and see what one's bigger, what one's smaller, what does this mean in this specific situation. Okay, so that's a review of our topic 4. One more thing on topic 2. I want to make sure that we understand that when we see the box plots, that every single one of these pieces is 25% of the data, regardless of if this is longer or shorter. Each of those is 25%. So letter C says 75% of the female weights are above what value? So I want 75% of the female weights to be above what value? Well, if I start here, that means that 100% are above this value, the minimum. If I move up, that means 75%, 50%, 25%. Remember, it wanted 75%. So 75% of the female weights will be above this value. That value is Q1, and I can tell that Q1 is this 106.5. And that's all I really need to answer for this question. It's going to be 106.5. We'll make up that this is pounds. Sorry, I'll rewrite this better with a unit later. Letter D says 25% of the weights for the males are above what value? So let's go to the male weights. Right now, here's 100% are above this. 75% are above this value. 50% are above this value. So 25% are above this value. And that value corresponds to Q3, which is 172.5 pounds. So we'll say that this is 172.5 pounds. The last question says 50% of the female weights are located between which two values? So we just need to say have two boundaries that give us 50%. Well, you guys, each of these is 25%, isn't it? And so my favorite one to use is the IQR, is something like this, because this would have 25% and another 25%. So I could say between Q1 and Q3, so between 106.5 and 146 pounds. Now I'm going to happy cloud that answer, but there are other values that it could be too. Aren't there other places that you could find 50% of the data? Another place could be between 0, between the minimum and the median. This also contains 25, 50%. So you could also say that this answer was the minimum, 93 pounds, and the median, which was 121 pounds. So that could work as well. But there's even another one, right? We also could go from the median up to our maximum, and that would be 25, 50%. I know it's spread out more, but 50% of the weights are still contained in there. So we could also go from our median, which was 121 pounds, to the maximum, which is 185 pounds. Okay. In a test situation, you really should only have like one option, so don't worry about it. But if you feel that you find another one, feel free to list it. So this is just a little review of everything that we've done. 1A, was topic 1 on histograms. 1B was topic 3 on describing distributions. 2A, C, D, and E were topic 2 on boxplots, and 2B was on comparing distributions. Okay, so that's all for this, and now we can just work on the multiple choice review, and good luck on your test. Have a great day.